So in this video, we're going to take a look at how to solve equations that involve algebraic fractions. So we're going to bring together some work on quadratics, on our algebra, on fractions, and it's going to get quite messy and complicated here. So we've got to take our time, make sure we write things out very carefully. So one way of doing this, and there are many ways of doing this, is to try to create a situation without fractions. Right. So, for example, in order to clear and make an expression without fractions from this first example, I could multiply both sides by, for example, x minus 6. Or I could multiply everything by x plus 2, or I could multiply everything by 15. And we want to do all three of those, and that is going to cancel out some of the work from the denominators, leaving us with just a line of algebra, a regular equation. So let's start off by multiplying everything on both sides by x minus 6. Remember, we can do that as long as we keep the same thing on both sides. So on this left-hand side first, if I times this first a piece of algebra there, that algebraic fraction by x minus 6, it's going to cancel the x minus 6 on the denominator, which means that'll just be x. On the next fraction, let's just write it as x bracket x minus 6 all over x plus 2. Remember, when we multiply a number or a fraction by an expression, it multiplies the numerator. And then on that right-hand side, we'll have two lots of x minus 6 all over 15. So that's our first step, multiplying both sides by x minus 6. And that's removed one of the fractions. Now let's do the same thing again, but this time we're going to multiply by x plus 2. So if we multiply both sides by x plus 2, we'll have x timesing by x plus 2. In that fraction, we're going to cancel out the denominator. So we're just left with x, that bracket, x minus 6. And then on this right-hand side, we're now timesing that numerator by x plus 2 as well. And we have cleared the second fraction. Finally, we're just going to multiply both sides by 15 to get rid of that divide by 15 on the right-hand side. So if we do that, we're going to have 15x bracket x plus 2 plus 15x bracket x minus 6 is equal to 2x minus 6 x plus 2. Now notice I haven't done any expanding yet. I could have done, but I want you to stay with me and follow this example very carefully and as easy as possible. So now we'll start to expand these brackets and see if we can simplify this into something that we can solve. So let's start with the left-hand side. If we expand that single bracket, we will have 15x squared plus 30x. The next bracket will be 15x squared. Now, 6 times 15 is minus 90. So we're going to have minus 90x. And then let's expand this right-hand side. So I'll keep that 2 outside the bracket. So we can just multiply out the x minus 6 and x plus 2. Now, I'll do this, look, with a little table here. I'm sure most of you can do it in your head. But I'm going to have x squared, a minus 6x, a 2x, and a minus 12. So overall, I'm going to have x squared minus 4x and a minus 12. And perhaps I could just multiply that by 2 now. So we'll actually have 2x squared minus 8x minus 24. There we go. Let's get rid of that and write that in there. So I've expanded the 2 at the same time. Maybe I'll write it again above just to keep it neat. Okay, so there we go. We've got the expanded version now of the equation ready. And now let's see if we can simplify this further. So let's collect up terms. So on the left-hand side, I've got a 15x and another 15x. So that means I've got 30x squared. 30x minus 90x is going to be minus 60x. Now, I'll keep the right-hand side the same now, but already I can see this is turning into a quadratic. So let's keep that positive coefficient of x squared. So I'm going to move everything now to the left. So I'm going to take 2x squared from both sides to give me 28x squared. I'm going to add 8x to both sides. That's going to give me minus 52x. And I'm going to add 24. So that will all clear that right-hand side. And now I'm worked my way down towards a quadratic that I might be able to solve. Okay, so from here, let's see if we can solve it. So I've noticed already, though, that everything in that expression on the left will divide by 4. So let's divide everything by 4. On both sides, nice and easy on the right, it's still 0. I'm going to have 7x squared. Now, if I do 52 divided by 4, it's going to be 13. So minus 13x, and I'm going to have a plus 6 there if I do the 24 divided by 4. Okay, now from this point, I'm not sure if I can factorize this or not, so I'll play it safe. I'm going to solve this with the quadratic formula. So A is 7, B is minus 13, C is 6. So if I substitute this in, I'm going to have 13 plus or minus the square root of 169 minus 4 times A times C. So 4 times, well, 7 times 6 is 42, all over 14. Now, let's see if we can simplify this. Okay, so if I can simplify this, well, 4 lots of 42. Well, 2 lots of 42 is 84, so we're going to have 168. So we're going to have, in total, we're going to have just the square root of 1 in that square root there, look, and we're going to have a 14 there. Now, square root of 1 is just 1, so we're going to have 13 plus or minus 1 over 14. This is going to give me 2 solutions. So the first one is 14 over 14, which is 1. The second solution is going to be 13 minus 1, so 12 over 14, which I will simplify to be 6 over 7. So my answer to this original equation is x equals 1 or x equals 6 over 7. Okay, so let's take a quick look back. Let's just summarize. What did we do there? Well, we multiplied by the denominators. That cleared the fractions. Next thing we did was we simplified as much as we could to write them without brackets. Third thing we did, we created a quadratic expression that was equal to 0 on one side, and then simplified that by dividing by 4 as much as possible. Fourth thing we did is we used the quadratic formula to find a solution. Perhaps we could have done it by factorizing, but under these circumstances, it was easier to do it by the quadratic formula, and certainly that will work every time. Okay, let's have a look at one more example. These examples are long, so we won't do too many of them. So let's see if we can figure this out again from the beginning. So step number 1, we're going to multiply everything by x, then x plus 2, then by 3. That's going to clear out those fractions. Okay, so we'll start by multiplying both sides by x. This is going to give us 1 plus x squared over x plus 2 equals 5x over 3. Step number 2, we're going to multiply both sides by x plus 2. So if we do that, we're going to have x plus 2 plus, and we're going to cancel that denominator, just an x squared, and that's going to be equal to 5x timesing by x plus 2, all divided by 3. Step number 3, we're going to multiply everything on both sides by 3. On the left-hand side, we're going to have 3x plus 6 plus 3x squared. On the right-hand side, we are going to just get rid of that denominator. We're going to end up with 5x, x plus 2. Okay, so we've managed to create our first stage. We've got rid of all the fractions. Step number 2, we're going to simplify this by expanding brackets. Then we're going to collect it all up to one side, ready for a quadratic formula. So if I expand the brackets first, and perhaps we'll rewrite this left-hand side in terms of the leading coefficient of the leading power of x first, we're going to have 3x squared plus 3x plus 6 is equal to 5x squared plus 10x. Now we're going to do that move all to one side. Now this time I'm going to move everything to the right rather than to the left. And this is so I keep the coefficient of x squared positive. So I'm going to start by moving the 3x squared to the right-hand side. So taking that away from both sides. That'll leave me with 2x squared. I'm going to take 3x from both sides, and that's going to leave me with a 7x there. And I'm going to take 6 from both sides, so I'm going to have a negative 6 there. That will leave 0 on the left-hand side. And now, again, we're ready to use our quadratic formula. So A is 2, B is 7, C is negative 6. I'm going to put those numbers in now. So my value of x, our solution is going to be minus 7 plus or minus the square root of 49. Now I'm going to have a minus of a minus because c is negative. So already I'm going to write the plus sign in there. And it's 4 times a times, which is 2 times 6. So it's going to be 4 times 12. We'll simplify in just a moment. All over 4. Let's see if we can simplify that square root at this point. So 4 times 12 is 48. So 49 plus 48 is 97. So we're going to have a square root of 97 all divided by 4. Now, I don't know if we can go any further than that. 97 is an awkward number to simplify. We can't break it down. We can't do much cancellation. We can't use our work on surds in a previous video. So that will do. Now, we could write minus 7 plus root of 97 over 4 and minus 7 minus the root of 97 over 4. But it's standard practice just to say x equals that expression there. I'm not going to find it as a decimal. I'm going to leave my answer in that format, that exact format, and we're finished. Okay, I hope that this video helped you to understand some of the techniques that you can use when you're solving complex algebraic equations that involve fractions.